Hi, my name is Singer. I'm going to talk about our objective and introduction.
In this assignment, our objective is to simulate plant-wide process in Unisim to apply PET depolymerization in supercritical methanol to commercial recycling, and to investigate from the viewpoint of the reaction rate and energy demand. PET is polyethylene terephthalate. It is well known as plastic bottle material that is transparent and light. It is cheap and durable, so it is widely used as food and beverage container, including soda, instead of glass bottles. The strength and stiffness are the largest of the ordinary plastics. It has highly heat resistance property and high thermal temperature. Also, it is excellent in electrical characteristic and good mechanical strength and coloring. PET could be recycled completely and thus is the most suitable for a recycling-oriented society. Therefore, chemical recycling by depolymerizing PET that has been gaining greater interest as either recycling method. Chemical recycling process by metalysis is the one of the methods. It consists of depolymerization in supercritical methanol section with the continuous reactor and monomer purification section. It will discuss the benefits based on the total heat demand of the process and simulate by using Unisim.
My name is Wong Zheng-Yu.
Hello, my name is Yao Juyi.
My name is Yao Jamie, and we are going to explain the methodology for this simulation.
Unisim Design Suite is a very powerful process simulation software for steady-state chemical processes. Basically, the material component required for the simulation of the depolymerization process are polyethylene terephthalate PET and methanol as the reactant, and dimethyl terephthalate DMT and ethyl glycol EG as shown in the component list. However, due to Unisim databank did not include PET, bis 2-hydroxyl terephthalate BHET were used instead as a model component of PET. PET is an organic compound consisting of ethylene glycol and terephthalate acid joined together by an ester as an intermediate in the production of polyethylene terephthalate. BHET has a very similar chemical composition and structure as PET as shown in the figure here, which make it justifiable for replacing PET. In our case, the fluid package of Pink Robinson was used to perform thermodynamic calculation on Unisim. The physical properties of each component were based on the process data bank in Unisim. To simplify the process, it is assumed that there is no other side reactions occur during the PET depolymerization process, and the only products are EG and DMT. The process flow diagram depicts the depolymerization of PET into DMT and EG in supercritical methanol. The process consisting of mainly three sections: the depolymerization of PET, purification of products, and recycling of unreacted feeds, with each unit operation has its own function. Our requirement is to process 100,000 tons of PET per year, so we converted it to around 11,000 kg per hour of PET.
In version 1 of our simulation, we feed methanol, excess methanol into the mixer, inert at 0.05% hexane, and 11,456 kg per hour of PET into the mixer. Then the mixture will go through a pump to increase the pressure to 14,710 kPa, and then heated up to 573 Kelvin to establish a critical methanol condition. Then the mixture is fed into the reactor to undergo the polymerization process at 90% conversion, as shown here. All the products go out in the first stream and then is fed into the methanol column. The design specification of this methanol column is 0.17 reflux ratio and component recovery of methanol at 99.99%. The recovered methanol in the distillate stream is recycled back into a mixer with a makeup stream and go back to the feed. The bottom product from the methanol column goes through a valve and then is fed into the EG column. This second distillation column is designed based on reflux ratio of 0.36 and another component recovery of EG at 99.99%. The distillate stream consists of 8,264 kg per hour of mostly EG. The bottom's product also goes through a second valve and fed into the third column, which is a DMT column. In this distillation column, the design specification include reflux ratio of 3 and component fraction of BET at 0.872 instead of component recovery. So the distillate stream consists of our second main product, which is DMT at 0.9999 mole fraction. The bottom stream consists of a mixture of DMT and PET, unreacted PET, which is around 10% of the feed. The bottom stream goes through a pump to increase the pressure to atmospheric pressure and then recycled back to the feed with a makeup stream. Both makeup streams are calculated using adjust function so that the required 100,000 tons per year requirement of PET input is maintained. The stream table of this simulation can be found here, as shown. So the temperature, pressure, molar flow, mass flow, and mole fraction of the components of each stream is shown here, and this stream table will also be attached in our report.
This is the version 2 of our simulation. The difference between version 2 and version 1 is the feed inlet of methanol and PET increase the temperature and pressure individually before mixed in the mixer. From reactor onwards, the process condition is same with the version 1. In version 1, the total power required of pump and heated is 23,604.3 kilowatt, and in version 2, the total energy required of pump and heated is 22,863.41 kilowatt. So by using the arrangement in version 2, we can save at least 740.89 kilowatt of energy.
Hello, my name is Utilising. I'm going to talk about the conclusion of this project.
The case study is comparing two versions of the polymerization of PET with methanol, and we assume a simplified process flow and simulate each process by using Utilising. So the top recycle stream is the recycle stream of methanol. So for the first version, the recycle stream of methanol contains a molar flow rate of 1,884 kg mole per hour. But for the version 2, it contains 1,713 kg mole per hour, which is much lesser than the version 1. So for the bottom recycle stream is the recycle stream of PET. So for both the version, it contains not only PET but also a small amount of DMT. Therefore, the DMT will be recycled throughout the process until it extinct. So for the EG column, for version 1, a EG of 0.82 of mole fraction was obtained. For version 2, a more pure EG was obtained which has the 0.96 of mole fraction. For DMT column, for the first version, a DMT of 0.999997 of mole fraction was obtained. For version 2, a DMT of 0.999979 of mole fraction was obtained, which is less pure than the version 1. So in conclusion, for the first version, it can recycle more unreacted methanol and obtain a more pure DMT, but a less pure EG than the second version. It also requires more energy demand to complete the process in overall as well.